Morning, everybody. Hope you guys are having a good day. All right, so I've got a panel today that consists of kind of users of quantum, not developers like quantum machines, but really more on the user end of that. And so we're going to talk about kind of what my panelists think are like applications, that they're using in their current organizations, or they see in the next 5 to 10 years as the killer apps for their respective slice of industry. Okay, so with that, my panelists today on the far left, your left, is Bill Wisotsky, Principal Quantum Systems Architect at SAS. Michael Hayduk, who is the Deputy Director for Information Directorate at Air Force Research Laboratory in Rome, New York. And then Michael Tait, who's a Senior Director of Emerging Technologies, General Dynamics Information Technologies. And then Zac Staples, who's the CEO of Fathom 5 and soon to be another company, Liberum Technologies.
Yeah, and Lorin, just for the introductory point, I'm glad they picked somebody much better looking to put in the picture than actually me.
Who are these
so
people?
that's not actually me.
People?
I've got a body double
Oh,
for
wow.
the
Yeah, that is it.
picture.
That is a body double. That's
That is
awesome.
a good-looking man right there. I wish that
I
was
don't know
me.
who that is, but maybe he's in the audience. I don't know. All right. Okay. All right. Thanks for that. Okay. All right. So I'm just gonna throw out some questions. If anybody has questions in the audience, near the end, I'll kind of stop. And if you want to ask questions, we'll get a mic to you so you can ask a question. Okay. But I'll kick it off here. So kind of the first question for the panel, and we'll start kind of left to right. What are your current interests in quantum, and how are you using the technology today? Bill?
So my interests, they're very wide. I love really researching the quantum hardware and the quantum physics that enable the quantum hardware to do its tricks. From more of an applied perspective, what we do every day is we're looking at the use of quantum computing to solve real-world applied problems that customers might have in the areas of optimization, the areas of machine learning, AI. And we're looking to see how that sort of quantum hybrid process takes place.
Thank you. So I would first start out, our AFRL Quantum Information Science program is broken out into 4 main areas, and I'll try to be brief on this, but we break it out into 2 near-term application areas, first being timing and sensing. So timing, you think of clocks, building better clocks. Sensors, things like magnetometers, gravimeters, you combine those two. Looking at application areas, how to operate in a GPS denied or degraded environment. Networking side of the house, we're looking at secure communications, how we can tie together quantum processors, maybe quantum clocks, quantum sensors. But we view that certainly as further out technologies, and I'll get into that probably later on. And then on the computing side, so we're certainly not building a quantum computer, but we're really looking how we can leverage what the commercial industry is doing. We have several partners out there, and really very similar, looking at problems such as optimization, machine learning, and quantum simulation or quantum chemistry.
Well, GDIT is a large system integrator, and we're always building solutions with technology that other companies have built. And so we're trying to bring mission enhancement to our customers. And so we leaned into the problem about 3 years ago. Our CTO got with me and said, we need to get into the quantum space. And so we're looking across broadly, not just computing, but sensing, comms, networking, security. We've built a quantum post-cryptography offering. We're making that available to our customers and helping them understand how they can prepare for quantum cryptography issues in the future. We've got now contracts with some IC organizations doing quantum algorithm evaluation for various Intel kinds of requirements. Also working with quantum sensing companies to look at how we can bring quantum, say, photonics capabilities to bear on some of our customers' maintenance and other types of issues. We're looking at logistics to support, say, DLA with expanding their abilities to do more accurate logistics, less costly logistics. We're building a cadre of people who understand quantum computers now. We've been doing some training, and we've actually got our first quantum scientist position open. So we're sort of across the board looking for any place where we can enhance the mission of the customer. It can be incrementally. It doesn't have to be a major bang replacement of existing systems. In most cases, it's enhancements of existing systems with quantum capabilities that didn't exist a few years ago.
Cool, yeah, all interesting stuff. We're coming at this from a slightly different angle. We're trying to solve a problem that we have seen across the U.S. defense space for 20 or 30 years. And it's simply this. It's that the United States does the most amazing technology demonstrations and builds the most impressive defense prototypes in the world, and the Chinese build 10 times more ships. Because so we're doing neat stuff and exercises off the coast of San Diego and Honolulu without the ability to move that to scale. And so we see this 3 to 5 year horizon on quantum sensing and technologies and are asking the question today, what has to be true about the hosting environment on tactical platforms so quantum technology has a place to land, so that we don't end up in the same situation we've been in with AI/ML for literally the last 5 years, where we can do a lot of interesting things with AI and ML. We just aren't doing them on warships, submarines, or in fighter jets. And so by getting after the integration problem early, we're looking to orchestrate these capabilities into something that actually makes a difference for national security the day the payload technology becomes available and ready.
Yeah, and I'll just really add real quick. So my last job in the Navy, I was the chief of naval research. So I ran the Office of Naval Research Laboratory. And in that role, when I came to the job, which was in 2020 to 2023, one of the focuses I had was really kind of getting into this world of quantum sensing and quantum timing. Michael mentioned that. A lot of people said, why aren't you doing quantum computing? I'm like, look, I think was too far out for me and my horizon at that point in time. And quite frankly, there are other parts of the government, DOE, the IC, that were more focused on that. And so for the Navy, it was really more the applications of sensing and timing that I saw as transformational to the way we do operations. I mean, think about a submarine that has to periodically come to the surface to get a navigation fix and to kind of ensure its timing is synced with the satellites. Well, if you had quantum sensing on board and quantum timing on board, you could negate the need for that. Instead of having to do it once every 12 to 18 or 24 hours, you could do that like once a week or maybe once a month if you get the right accuracy. So transformational in the way we operate. And so that was kind of the focus that we had at the time when I was at ONR to try to push those technologies forward. And a lot of great work was done by the Naval Research Lab, which had a big quantum timing initiative under the Defense Department. So those efforts continue to this day. AFRL is heavily involved as well. So a lot of great work happening there. So, okay. All right, next question. What applications do you think will be, your organizations will be working in say 5 years or maybe even 10 years that you think will transform your lines of business? Bill.
So I think within the next 5 years or so, I think that the quantum hardware manufacturers will get this error correction problem solved. I think a lot of the mitigation techniques that we have now, once that solution comes, we're not really going to need them as much. So I think that things are going to shift from error correcting and testing those algorithms out to more of an applied perspective. And I think that in 5 years, right now at SAS, we're kind of looking at different pieces that quantum could fit in, and I think that it's not definitive yet, right? If AI will benefit from quantum or machine learning will benefit from quantum. In some cases, we see some evidence. In other cases, we don't. But I think in 5, 6, 10 years, I think that AI is going to be very heavily influenced by quantum computing, and I think it's not just going to be in general AI. I think it's going to be large language models. We're seeing research being done in that area now that looks somewhat promising. I think that machine learning, I think optimization, it's funny, maybe 15 years ago, SAS has a consulting division that we focus on government contracts. And I was part of that, and I worked for the Department of Defense and Homeland Security. And every single problem that I worked on back then was some form of optimization problem. It was trying to optimize this or that or any of these things. I think that's going to be a very big field right now, even more so than it is.
Hey, Bill, can you? I read something you put out where you kind of described how quantum actually will help solve that optimization problem. It had to do with hiking the Adirondacks versus being. Can I explain that to the audience?
Oh, yeah, sure. I always use that as an example. People say to me, ask that question all the time, and I think that if you were to take a look at optimization, how quantum optimization works. If I was to turn around to you and place you somewhere in the Adirondack Mountains, and I use that because I'm from New York, I use that mountain range, and I used to go hiking there when I was a kid. If I was to put you in the Adirondack Mountain range with just, something to record where you've been, like the paths that you've chosen to take, and I said to you, there's a lake at the lowest point in the mountain range, I need you to find it. Well, you would start off and you would start looking for this lake, and you would, try one way, try another way, and it'd be mostly trial and error. And you could, if you ever been to the Adirondack Mountains, it could probably take you a lifetime to find this lake. If I was to have you solve that same lake, but give you the power of like a quantum computation or use something in quantum, it'd be equivalent to me giving you a helicopter, right? And allowing you to hover above the mountain range, and you could explore the entire mountain range at once and see all the possible solutions all at once and say, yeah, there's the lake, and that's how I'm going to get there. So that's that example.
Yeah, thanks. Nepper, you love that.
So what I'll do is I'll piggyback off a little bit what you said, Lorin, in terms of nearer term applications. If we look at the within 5 years, certainly quantum sensing, quantum clocks are something we're heavily focused on in the Air Force. Partnered with the tri-services. I can think of a couple of things here to really hit upon. The first was, it's great to keep doing the research loop within the lab, but our job certainly as, in the services as part of the Department of War is to really get technology out into the field, right? To be able to transition and move it out. And quantum sensors are ready to be able to do that. So we've done a lot of work, I'd say, the past few years, dating back several years now, as to how to actually do that in terms of field experiments, field trials. And we've learned a lot from that we've been able to bring in. I think a good example where we kind of partnered the Army and the Navy would be RIMPAC 2022, right? Where it was just a bold vision of, how we could take quantum sensors, quantum clocks, partner with the Five Eye Nations, put them in the Pacific for 3 weeks and see how they operate. And, we learned a lot from that. And it was actually, I think, more successful than we thought it would be. And certainly the Navy led the way with Dr. Willis. He was just phenomenal in the job he did with that. But we've been able to take that and then loop it back and, now do some flight tests. And, as we think about sensing, right, magnetometers or gravimeters and how you put those together in GPS systems, we have programs out there in the Air Force, and DIU has a transition of quantum sensors program where it's really, all right, we're going beyond research. We're actually now taking this out in the field and seeing how this will compare with, operating in GPS environments or, even non-traditional PNT systems, position, navigation, and timing systems. So we have that. Air Force, we've done work, magnetometer systems, magnav systems, similarly. So we're going to have to keep kind of pushing on that. I think those will be our first bites. And then longer term, past the 5 years, I think quantum networking is something that we're going to see some early instantiations of, really proving things out. I was really encouraged just last week to see an announcement from IBM really showing how they're going to be working with Cisco systems on developing quantum networks to link together quantum processors. And that's something we've been working on for several years now. So it's exciting to see some of that momentum, but it's going to take some time because it's a hard problem.
Yeah, I think in the next 5 years, we're going to see an expansion of what we're doing right now, but just more ubiquitously built into what we're delivering to our customers. We do a lot of stack development, some of the investment that we do in our organization to find out the right tools and technology that really we can get in a pre-deployment out, do demonstrations of, and then have a stepping stone to go into a customer's site and very quickly roll out capabilities. What we're doing is we're starting to weave in and make investments right now with bringing quantum into those places. And we don't really want to make it a big deal that quantum's there. We want to make it just an enhanced capability that's a differentiator because we're innovating, we're bringing in early technologies that maybe some of our competitors don't. And so we really want to have it be part of the fabric of what we deliver to a customer across the board, whether that's networking, sensing, compute. I also think there's going to be a lot of education that we're going to be doing. A group here in the room right now that we're working with to come up with some quantum discovery activities that we can take to our customers to help them understand, where quantum might fit in, and then with those capabilities that we built on the background, be ready to then move that capability into their organization much more quickly. And building on our cadre of staff. workforce development is going to be a big deal for us. We're going to be hiring folks that come in with quantum in their DNA and make them part of these mission teams that are bringing mission enhancements to our customers. So I see it really, pervading what we do as an organization, but becoming less sort of a new fancy shiny toy and just more an effective solution that just delivers value to the customer to make their, mission execution better across the board.
Yeah, I love that. I think where we're at and what we see in the next 5 years, Lorin, is just to echo some of what we heard in the plenary session. So this morning in the plenary, we heard Google talk about how they're staging and how there's a gap in the application space. We heard the kickoff keynote talk a little bit about how there is all this, he called it banal work that has to happen. It's not the quantum stuff that ends up blocking these companies, it's everything else. And so I think what we'll see over the next 5 years that's important is really two things. One, we'll see application development where we can say this is a quantum capability that specifically solves a quantum problem, which we don't have today. We talked about we have the big three and that's it. But we're going to see the quantum tool to quantum problem space grow. And then the second thing where we're going to be involved is, okay, how do we run that problem where the user has demand? And I think that goes a lot to what Mike was talking about also, is to get it out of the lab, you have to be able to take the tool and the problem and pair them, and you have to be able to run that solution in the place where the problem actually exists. And if it's at the tactical edge, if it's 1,000 miles away from everything, that's a big challenge. And particularly that's going to be a big challenge for quantum computing, because the quantum computers won't be there. They'll be somewhere else, right? And so and you get to the quantum networking thing just starting to crack that open. How we get the quantum appropriate problem from the place where the data exists to the place where the quantum computer exists to solve it at the pace of relevance is one of those just infrastructure layer problems. Nobody knows how that's going to work. And I think we'll have a better picture of how that's going to work over the next 5 years.
No, I think that's absolutely right. I think one of the things Michael Tait said about workforce development and just training is critical, because I find oftentimes when you approach, whether it's government or an industry person who has a problem that is a potentially quantum problem, they don't know how to articulate that or how to actually even put that in words. So if you're trying to ask them to, help you develop a proposal, they really don't know how to do that. And again, it's not because anybody's stupid here. It's just we've not been trained in that way. I mean, I was 37 years in the Navy. While I did study quantum at MIT, I'm a rare bird who had some insight into that. Most people had no idea. And so it's really very much a training thing that has to be done so people understand what are the quantum problems and what are not. What is a classical and what's a quantum? And most people just don't know that. Okay,
by the way,
folks like these right
just
here.
to Matt Johnson's credit, I actually wear my Q2B t-shirt. It's like one of the few. How many conferences do you go to and you get swag? I actually wear the Q2B t-shirt because it's got those little qubit guys on it. It's kind of a theme they do, and people are like, "What is that?" I mean, it's a qubit. I've started more actual conversations with people about what quantum is or could be based off the t-shirts they do here.
You're promoting quantum literacy right there. Right?
I'm trying, man.
That's important. That's good. Let's keep doing that. Okay. All right. So since we're really all primarily quantum users here, if you were talking to a quantum computer developer, what advice would you ask them to do for you that would help enhance the use for you in a future application?
So that's a good question, and it's an interesting question. At SAS, we have the benefit of being our own sort of customer zero at times. And we go through the same pain process that a customer would go through, sort of defining the problem, seeing how quantum might or might not fit in. And there's various sort of challenges that we found at each stage of this, beginning right from the very start, right? If you look at a problem from a data science perspective, you're probably not going to see the quantum aspects of it. If you look at it purely from a quantum perspective, you're going to come at it from too scientific perspective, it's not going to be applied. If I was to be able to, and then you start adding to the stacks, right? Different Python versions, different SDKs, different algorithms. And, at the end of the day, right, if we want quantum to be used by users, we have to make it more friendly. users are not going to want to have to build quantum circuits and quantum algorithms. They're going to want to use those quantum algorithms the same way that they want to use a chat GBT. They're not worried about the quantum algorithms, the regular classical algorithms under the scene. So that's what we're kind of concentrating on at SAS. And one of the biggest sort of bottlenecks that we found is the simulators work great, right? The quantum simulators work great. You build your algorithms. But then when you want to flip the switch to go on to quantum hardware, some vendors make it really, really easy, right, to flip that switch. Other ones, you have to redo all of your code in order to just direct it to the quantum hardware. That switch needs to be easier because in a real-world situation, a customer is going to probably do a lot of simulations, right, before they actually run it on a quantum computer. And to flip that switch should just be a very simple process. So that's where I would kind of concentrate things on that switch flipping between the simulations to the quantum hardware. Like I said, in some cases it's easy, in some cases it's very hard.
Yeah, well said. I think for us in the Air Force, when we think quantum computing in particular, where we want to see it go, certainly the continued push of the hardware, right? And we're certainly not at a stage where we heard it in Joe Altapeter's talk today, right? Of picking a winner, right? There's still a lot of contenders out there, a lot of different qubit technology. So certainly seeing the hardware continue to move forward as fast as we can is critical. I think also finding out what quantum computers are really going to be useful for the Air Force is a big problem, right? So we talk about the big three. We're seeing some really cool indications with the program we have going on right now on supply chain optimization and management, and just how big that problem can be, right? You think about it as maybe delivering something, but when then you add in all the illities, whether it's sustainability, reliability, et cetera, right, that becomes an infinite problem. So seeing problems like that continue to be out there. And then, what other algorithms are actually going to make a difference that can be put on practical hardware. And I think, too, what I'd love to continue to see, or maybe even more from quantum computing companies out there, is just, less hype. Right, there's certainly a lot of selling to high levels. I'm sure you encountered it, going to certain levels of the Pentagon and trying to get us to buy systems or what have you from different vendors, and not practical right now. We need to continue to figure out where quantum computers are going to be very useful for as we look down the line, and how that will compare, not just quantum for the sake of quantum, but are you solving a real problem that can't be solved now? So hence quantum advantage.
Yeah, I'm going to foot stomp something, Bill, you had said, and that's making it more accessible. Accessibility is really going to be key. I'm seeing that right now in the industry with Classique and Strangeworks are two companies that are sort of building out compute programming environments that integrate well with the classical systems. And so that's a valuable set of tools that are growing. And I expect we're going to see more in that area. But that's going to make it much easier for technologists and programmers to just integrate quantum into a workflow, because that's where it's going to be. It's going to be in a classical workflow as the primary kind of place and location. The other part about that is the data models that need to go into it. A tremendous amount of time is spent just figuring out how to structure the data well. What are the best practices for data? So you're bringing things through a classical workflow, and you need to take the data and put it into a quantum system. Well, it needs to be done a certain way for different types of algorithms. So I'm hoping that we'll see a growth in data management, data algorithms. Some of these platforms may even will build some of these tools for making it much easier to take your classical data and put it into a quantum structure so that you can put it into the machines. And then some obfuscation of the actual quantum types of modalities of the machines. Because I think the different modalities, they're all going to get it. They're going to get to one place where they can be useful, and they're going to be certain modalities that are going to be useful for different types of problems. And so being able to skip and pick and use the right modality for the right kind of problem is going to be useful. And even just for valuation and checking, right? So running through an algorithm through multiple different modalities and being able to figure out what the best answers are and where they're coming from. So all of that all that complexity is part of what's in the offing right now, and that's what I'm hoping over the next 5 years is that the development community is really simplifying this and making it much more accessible, so that you don't really, There will be people who need to have quantum science degrees and can work in this, but the vast majority of uptake is going to come from people who don't have quantum backgrounds, but understand quantum and how to apply it, and give them the tools to make it be applied very quickly and effectively.
Lorin, you asked, what advice would I give a quantum company to kind of be at that really good state in 5 years? I'm going to take a different direction, just kind of having run companies for a while than everybody else said here. Build a company that's ready to catch the car. So the dog is running, chasing the car, and all of a sudden gets the bumper, and then realizes because he gets drug off at 60 miles an hour, oh, I wasn't ready for that, right? and so most quantum companies are research companies right now. And researchers have a different opinion about, maybe I'll finish my dissertation this year. Maybe I'll go take the Fulbright scholarship in Germany for a year. Then I'll come back to Harvard and finish the PhD, right? But that ain't going to work. If you catch the car and your thing works, you need a team of people that are designed to deliver on budget, on schedule, and go catch the follow-on contract. And so from a company organization, what I would say is most quantum companies that I meet are set up as research companies. And when I'm like, hey, who's the deadlines guy around here? Oh, I don't know. And so my advice is build a company that is ready to catch the car, that has a different breed of person that is ready to deliver on time and on budget for your first set of customers, so they come back at 10x, because they've got the money if it works. But you got to have a team that can deliver for them.
All right. The dog's going to catch the car. So, all right, got it. Okay, I'm going to ask one more question, then I'm going to kick it to you guys. So be thinking of your first question here. If not, we've got a few more. But, okay, so starting with Bill again. If you had to pick it, what do you think is kind of the one, app that quantum would solve that you'd want your organization to go after first? What's that one application that you really want to go after first? Doesn't have to be a long answer, but just what's that area that you want to go after?
I really think that the future of quantum is going to be in the quantum AI. Like I think that's going to be a big area, and that's where if I could make that decision, I would devote a lot of resources to building some sort of integration of applied quantum AI, whether it be in LLMs or you could use it for whatever. But I think that's where it's going to be. It's funny that you asked that, because I remember being a kid and seeing the TV, the news with Steve Jobs and Steve Wozniak building Apple computer in their garage, and thinking, where would this ever go, right? I mean, you would put a tape in there and you would type load, wait half an hour, and then get syntax error at line 33, right? And have to do the whole same process over and over and over again. I didn't know.
I didn't get the syntax errors. I guess that was just you.
You didn't really quite know where computers were going to wind up back then. The same thing, and then cell phones came along, and you had the suitcase cell phone, right? And then you didn't know where that was going to wind up. In a million years, I never would think that the cell phone I have in my pocket here would be more powerful than any of the computers I had in college. And that sort of thing repeats itself, even the internet, right? When you had AOL, right? And then tying up your phone line and your parents yelling at you for tying up the phone line the entire time. So making that sort of like what is the next app, right? It's a hard thing to say, because our imaginations are kind of what dictate where that goes. And if we build something that taps into something that a customer wants, it's easy to use. You look at your iPhone, it's a perfect example. It's a very easy device to use, and that's what does it. So I think that from our perspective, we're looking at bringing quantum into our sort of product stack, where it's a point and click, easy to use. You don't need to be a quantum physics to run quantum. That's what we're working on. Within that, I think that whole AI, the quantum AI, is going to be the next thing, because it's just hopping on to what's popular now, and it's just, extending that.
Yeah, it's a great answer. I think from the Air Force perspective, I would make it near term, right, which is the PNT problem, right? I would absolutely want to see more resources devoted to the PNT problem, right? This PNT is a big problem. It's a here, it's now, people are in harm's way, without a doubt. So solving that problem is, looking at that problem has been looked at, working at that problem has been looked at a long time now. but now we can bring quantum into it. And quantum will enhance things like, you know, the resolution, the accuracy, the timing, et cetera, all those things, the recalibration time needed. So bringing quantum into it is something we have to do, and something that's very much needed. And I think what that will allow us, though, is, you know, as you fold into those quantum pieces, you know, it applies to quantum networking, it applies to quantum computing in terms of the hardware. So we'll continue to learn a lot of that, but we'll get a real near-term win for quantum, which is needed.
Yeah, and a couple of different areas that I think we could be focusing on. One is in the sensing areas. Make those things more portable, smaller, able to be more edge deployed, be able to have form factors that can be manipulated rather quickly, so that the different sensing capabilities could be put into different sort of replace existing sensing capabilities or classical sensing capabilities. We're seeing that in a number of different areas. It's not real sexy, it's not real fancy, but it is going to make a big impact on the mission that we're starting to bring these tools to. And a lot of the research that needs to be done is just getting it into the right form factor and miniaturizing it. And some of that's just money, you know, in many cases. And so focus getting it into one area that is going to allow multiple deployments, right? And focus on that sort of a mission deployment type of a problem set versus the science of making accurate, you know, solutions. They need to come together. But if you can't deploy it and put it out on the edge and make it work rapidly, that's good. Bill, what you mentioned about quantum and AI, we're seeing that you know, with one of our programs we've been working on for a couple of years. They're starting to recognize that, you know, quantum in many cases isn't any faster than classical, except when there's not a lot of data. And then when you don't have a lot of data, quantum is actually able to generate models that are at the same level of accuracy that a classical system would. But a classical system would need 20 times, 100 times more data to generate the model. And the model generation is faster, and the accuracy is good. So I think that's an area of focus that you could incrementally make big changes in the whole model development process by rapidly bringing quantum to bear where it's appropriate, especially for minimal data sets. And then the other aspect of that is, or another aspect of that is large language model fine-tuning. We're seeing that in a number of areas where you could be using quantum to help you know, make more accurate or adjust models based on limited sets of data and be able to modify large language models to work in different domains with those smaller sets of data. Some of the capabilities that some of our partners are working with us on. And in the communications area, that's a key component. There's things that are already being deployed that I think they can focus getting those things into our comms environment, especially for the military and even for the intelligence community. And we're working on a program with a customer right now and with a partner that's going to rapidly deploy and change the communication footprint, allowing the existing radio systems to have more bandwidth because they're using quantum clock capabilities, because now there's more slicing of time in the sequence of communications. That's going to make a big impact pretty quickly. And then finally, the last thing is QKD. You know, we have been slow in the U.S. to sort of adopt QKD, but I think it's the next wave for PQC. And so right on the hills, that's one of the things our group is doing, is starting to look at PQC as being part of, looking at QKD as part of the package of PQC and delivering that in certain circumstances. Is it going to be needed everywhere? No, but there's certain critical areas where we could start applying it right now and looking at those particular use cases. So sort of across the sweep, those are sort of the areas I can see that we could be focusing on and get a lot of value very early into the quantum community and to the customer. And when it's impacting the customer, that's when the wallets open up.
Yeah, let me just kind of go last and summarize some of the stuff with some real practical examples, right? And I'll just take an example of the relationship between resilient PNT, that is in near term going to be provided by quantum sensing, and AI. So in the Navy, you know, the Navy is buying hundreds and soon to be thousands of unmanned boats and submarines and airplanes, as well as the Air Force, right? All of those have a navigator in them that is an AI navigator. the output of the quantum position sensor, position navigation and timing sensor, isn't the same like message string that you get out of a GPS sensor. So just one of those early apps that we see is kind of absolutely necessary is, how do I take the output of a quantum precision navigation and timing sensor and ingest that in an AI algorithm that is navigating all of these unmanned systems? It's a practical use case. It doesn't exist. It's not a standardized approach. And so again, and how would I update that at a regular pace on a cyber secure foundation, so that when we deploy quantum as the next information technology, we don't look back 30 years and go, oh man, we really should have done something about the security on that. We really kind of jacked it up. Let's get after that in these early quantum deployments, so we like what we have and it works well for us despite who's trying to make it not work.
Yeah, I mean, so often we wait until we deploy a capability before we say, oh, we got to put cyber in this thing.
Yeah, we built the
We're late,
entire
guys.
information technology infrastructure on Linus Torvalds after school project.
Yeah, that's right.
Like that
That's
doesn't
right.
make any
Pretty
sense.
Pretty much. Okay. All right. So who's got a question? Got a few minutes. All right, sir. We have an extra mic, or who wants to do his hands? Shoots out.
Yeah. So I'm thinking ahead, especially listening to Joe's speech this morning about getting to 2033 with practical utility scale on a computer. How worried are you guys about the cybersecurity footing of these machines once they arrive?
A lot. I mean, if we had to go one word answer, mine is 2, a lot. What is yours?
Yeah, I mean, that's an issue. We're already starting to think about that. Some of our partners were having conversations about, how are these going to be applied? I mean, I think the government needs to be thinking about who gets these things, right? And what can they use them for? What kind of, bounding box? But we don't want to, impact the industry and the growth abilities, but at the same time, they're going to be very powerful things. And so we don't want to find out after the fact that we should have done something. Right.
It's the it is the 100% catch a car problem. And if I can for a moment, I had a really distinct opportunity earlier in my career to accept the IEEE award for the first operating system, or CPM, on behalf of with Gary Kildall and his family. And at that, and kind of at the awards ceremony for all that, got to sit down with a lot of like the early pioneers from around here, and in building the internet, right? And talk to them about really what were the engineers. And I'm a cyber guy. I was a cyber weapons developer for a while, and now do a bunch of cybersecurity stuff for the Department of War now, I guess. But I got to ask them, hey, what were your engineering assumptions that you made that where we arrived 30 years later with this porous system where I literally have 10 guys from the stands lining up to rob for my mom every day over the internet that we built for her and exposed her to that threat. And I'm like, how do we goon that up so bad? And he honestly said, those guys who were early ARPANET, we didn't think about it. Because we were building a nuclear command and control routing system, and we knew that the two users on the other end of that carried their own cryptography and security, so we just had to get the message through. And so we built civilization on top of a routing system that had zero cyber security as an underlying principle. And man, we're about to do it again with quantum. So yeah, we ought to worry about that.
Thank you so much to all the panelists. Thank you, Lorin, for moderating.